One of the biggest issues in AI is the issue of explainability. Can we explain how our AI works? So you've got some inputs, here are some resumes, here are some mortgage applications, here's applications for admittance to a university, and we get an output. Yes, you get a mortgage. No, you don't get a mortgage. Yes, you're admitted to the university. No, you're not. And then the question becomes, well, what are the grounds on which the AI makes a decision? How can we explain its outputs? And for as long as I've been in this space, explainability has been held as a core value. But here as elsewhere, it's a lot more complicated. Why do we want explainability? At least from an ethical perspective, why would we want it? We might want it for various technical reasons having to do with we can make the model better if we understand it better, so we want explainability. But from an ethical perspective, and this is really what a lot of the conversation has really been about, why do we need explainability? So, in my book, Ethical Machines, I articulate a number of reasons why we might want explainability, including that we might think that in some cases we owe people explanations as a matter of respect. But the more that I think about this issue, the more I think maybe we don't need explainability. At least in certain use cases, we don't need explainability. Even high stakes cases. I mean, consider the following. Suppose you could have a cancer diagnosing AI that's 99% accurate. And let's say that the best doctors are 80% accurate. Which do you want diagnosing your child? Do you want the one that's 99% accurate or the human that's 85% accurate? It's not obvious, certainly not obvious, that we should go with the human because we more or less understand how the human works. Of course, there's areas to push back there about the human brain and how much do we really understand, et cetera, et cetera. But people can give explanations for why they make the decisions that they do. And we might think that we're more comfortable with that than with an AI that's a black box. On the other hand, performance matters. Being a better diagnoser of, say, cancer is an extremely important thing to take into consideration when you think about whether you want a black box or not. So, one issue that I talk about with Kristof is, should we just care about performance? Maybe it's just a matter of having benchmarks for safe deployment of an AI. And even if we don't really know, we don't have a deep understanding of how this thing operates internally, maybe it's been tested in so many circumstances, in so many ways, that we think it's sufficiently reliable and sufficiently safe to be deployed. That seems to me like a perfectly viable option. In fact, given that the data that we're gathering is only increasing and the processing power is only increasing, we're just getting to a place where we're going to have to use, I think, black box models. Now, related to this is, how good are these explanations anyway? I mean, what we're talking about when we're explaining AI are simplifications, and one might worry gross simplifications, oversimplifications of what the AI is doing, right? Because the AI is noticing these extremely complex mathematical patterns among who knows how many thousands of variables and bases its output on those mathematical patterns. That's what the black box problem is, that we can't understand those phenomenally complex patterns. So when we do get an explanation using the various kinds of tools that Kristof and I discuss in our conversation, there's an extent to which one has to worry that since we're getting simplifications, we're also getting distortion of the phenomenon and not just an explanation. So, one, maybe we should just care about performance. And secondly, one reason why maybe we should only care about performance is that the explanations are not that good anyway. They are distortions. The last thing that I want to highlight that I found particularly interesting in my conversation with Kristof is this issue of trade-offs. And I try to come back to this theme again and again, that whenever you have a commitment to an ethical principle, there's going to be some other kinds of ethical trade-offs. So for instance, in order to get explanations for how AI works, you've got to run some other kind of model. And it turns out that running these explanation algorithms costs a lot, computationally speaking, which means that not only does it cost a lot of money, but there's also a significant carbon footprint as a result of using these algorithms. So yeah, you might care a lot about explainability, but you also might care a lot about the environment. And there's going to be a trade-off. The more you run those explainability algorithms, the greater the environmental impact. And at some point, I would have to think it's not going to be worth the trade-off. How do we systematically make those kinds of trade-offs? Who makes those kinds of trade-offs? And on what grounds? Just another really interesting aspect. So while it's really easy to say something like, oh, we want explainable AI, as my discussion with Kristof reveals in a variety of ways, it's a lot more complicated than that. So this is, I will say, things get a little bit technical in this conversation, but I urge you to stick with it because I think there's a lot of great insights that Kristof provides. So as always, I hope you enjoy it and I hope you get a lot out of it. All right, Kristof. So the reason I'm excited to talk to you is black boxes, from my perspective anyway, they seem here to stay. And there are high-risk scenarios in which it looks like black box models could be really useful. But some people think that's not right. Explainable AI, in fact, in lots of the ethics statements out there, they're calling for explainable AI. So I wanted to get a sense from you. I know we've talked about this before offline. What are people doing about black box models? What are the tools they're using? Are they adequate to the task? And maybe, some reasons for why we should learn to live and love black box models. So why don't you start with how you tend to think about black box models and whether or not they're necessarily a bad thing?
Great. Thanks for having me on, Reed. Yeah, so I think this is a debate in the community, and generally the accepted view is that we do need some sort of explanation for these black box models. My opinion on this is that we're in this transitory phase of AI where people don't yet have the trust in the AI as a technology and as something that is necessarily going to benefit them. And I like to compare this to the automobile, the car. Basically, you can imagine when that first came out at the end of the 19th century, people were probably freaking out, like, what is this technology? Is it safe? And what's going on? And now if you think about people driving cars, I would say most people have no idea how their car actually works. And they ultimately also don't care how their car works.
Works.
Exactly. As long as it gets them from point A to point B and in a fairly safe manner, they're going to be fine with just getting the utility out of the car.
Yeah, sure. Sorry, but the driver doesn't know how it works, but the mechanics know how it works. The manufacturer knows how it works, right? So the manufacturer knows how it works, and I take that enables them to do certain kinds of testing so that when they release it, the average citizen using the software,
Yeah.
If it's cars, then the average driver doesn't matter. So then the analogy, we need to make sure that the data scientist or whoever's building the model understands how the AI works so they can do this safety things. And so that when it does get into the hands of a citizen or a developer or employee at some other company, they feel sufficiently safe doing it. So don't we need some people to have an understanding of what's going on inside? By that analogy?
Yeah. And I think in that, yes, you're absolutely right. I think in that sense, right now, we're in the stage where everybody is expecting explainability. And I think we're going to move away from that to where only really the experts who are very much in the loop will need to have some idea of how these things are going.
That's interesting because usually, I say this in my book, you need explanations for different stakeholders.
Yes.
Different stakeholders need explanations for different reasons. And you think, actually, no, that's not quite right. There's really we need to have a certain subset of all stakeholders with a clear understanding so that they do appropriate safety testing, but that's it.
Yeah. Basically, I think what we're seeing is these models are becoming more and more complex and more difficult to approximate with explainability method. Because I think what we need to remember is every explainability method is some sort of an approximation of what's actually going on. And the more complex the underlying model, the more crude that approximation has to be for us to understand. And so we might need to start shifting to a world where we need to verify the proper functioning of the AI by mapping the input space to the output space. And what do I mean by that? If we know what the inputs are and what the outputs are, and we have empirical data to look at those distributions and check for accuracy, for fairness, for all of these things based on the output, we're going to be able to, with high reliance, basically confirm the proper functioning of the model without necessarily understanding the complex decision making that is happening in the black box.
Yeah, so that's a view which I'm vaguely or roughly sympathetic with, which is something like, look, we just care about performance. If the thing is sufficiently reliable, then it's safe to use, or we can trust it in the way that you trust a bridge, that the bridge is not going to collapse when you drive across it. So the example that I like to give is, you have a magic box. Somehow we stumble upon this magic box. It's got 2 buttons on B. We have been maybe a bit reckless in how we tested, but we found out that every time we hit button A random person died. Every time we hit button B, a random person is cured of something. And we don't know how it works. It's a magic box. We don't know where it came from or anything like that, but we've done enough testing to now know. Looks like it's morally impermissible to hit button A. It looks like it's morally permissible, maybe even morally required to hit button B, because we've reliably tested its outputs. And so, why not think of AI the same way? We can test it on safer conditions, thankfully. At the end of the day, we can know how well the thing performs, and that's sufficient for trusting it, for safe deployment. That's right?
Exactly. And of course, the monitoring of the system is going to be crucial. There needs to be this constant monitoring where it doesn't suddenly start doing things that we don't want it to be doing.
Yeah, so, it's something like, you need to test its performance so that it's predictable how it's going to work. Or, sorry, the kinds of output it's going to give are more or less predictable. In the sense that you get wild, crazy things coming out. That's I think that. So, I take it, though, there's two things I want to explore. One is, it seems to me like other stakeholders do need explanations for how the thing works. And maybe you're not just counting this as part of explainability. If you build a tool, the tool user might need to understand how the thing works in order for them to wield it effectively. So if it's a fraud detection agent, right, the AI flags some transaction as fraudulent, it gets kicked up to the agent, the actual person, to review it. You might think they need to understand what kind of thing this thing is flagging, why it flagged it, so they can get their job done effectively. So don't they need explanations for how the tool is working so they can do their job well?
Yeah, absolutely. And I think in these specific technical use cases, you're still going to need to have things like feature importance, right? Like what are the top features that drove the decision that the AI made? And I think we're going to need to retain the capacity to be able to do something like that, almost regardless of how complex the AI becomes.
So let me make sure I have this right. So when you say, feature importance, there are certain aspects of, the transaction, certain features of the transaction, when the transaction occurred, where it occurred, it's when it occurred relative to other kinds of transactions, how the price of the transaction, or how much was trying to be transacted.
Yeah.
So those are different features of the transaction.
Was it part of a pattern for the account, or was it something that was just unusual for the account? Ultimately, that's what, let's say in the fraud space, that was what you're looking at.
Right. But what you're trying to figure out is, what are the features when something doesn't match the pattern? Like, usually Reed is pretty conservative, but it turns out that on Thursday he tried to purchase a car, a Lamborghini with his credit card. I don't think I have that kind of credit limit. And that breaks the pattern. And it's going to flag, there's certain features of that transaction indicate this is outside the normal pattern of Reed spending, and so it might be fraudulent. Let's take a look at it.
Exactly.
So I guess the question is, then, you said already, there's an extent to which, any explanation for what's going on inside the model is going to be a simplification. It has to be. If it weren't simplified, it would be just as complex, and thus we'd be left with the same lack of understanding. So it's got to be simplification. But I take it you think that the simplification, while it can go so far as to be distortion, there are ways we can explain what's going on inside, such that we can know what features played an outsized role or played the largest roles in determining the output.
Yes, and I would say a lot of the current explainability methods are giving us just that, which is and maybe just for a bit of context, there's generally the industry speaks of local and global explainability. And the difference between these is local explainability explains a specific decision by the model, a given data point, so to say, while global explainability focuses more on how the model works in general. In in it after many iterations, what are, let's say, the most important features that it uses to make certain decisions?
Right. So the global explanation is something like why, global explanations are something like, here are the rules by which we approve or deny mortgage applications. Whereas a local explanation is something like, here's why we deny a mortgage.
Yes, or even more specifically, even for global, we could say that the model relies heavily on FICO score in making a decision, right? If for a lot of its decision making, FICO score will appear as, let's say, one of the top 5 features, then we could say that that's a globally important variable for the
Right.
model.
And to me, one of the most important things about that is then you can ask questions like, is it a good idea that FICO score A should be part of the determination, should be part of grounds on which a decision is? B, let's suppose that it is a good thing to be part of that calculation. Should it be playing as large of a role as it is? So because we can get something around the explanations of how this thing is working, we can start asking, to my mind, the important, ethical questions about fairness, also questions about reasonableness, just sensibility, accuracy. Is this what we want to base our decisions on? I mean, doesn't this look like an errant variable or something like that? Or isn't it really irrelevant? Don't FICO scores track something else when you really look at them closely? And so you can have that discussion if you can, explanations.
Absolutely. And I think FICO score is actually an interesting example because FICO score itself is a bit of a black box. Right.
Oh, yeah.
And so you're using a black box variable to explain your decision making. But if we simplify a little bit, yes, if you look at the top features that come out of your explanation and you find that some of them aren't intuitive or maybe even more importantly, aren't merit based, right? You have to start thinking about what the implications of that are. Because if you have an important feature on the hobbies of an individual, for example, could that perhaps function as a proxy for an underlying demographic or protected characteristic,
Sure.
which the model picked up? So ultimately, it is very important to see, especially in these high risk decisions, what some of the reasons are for the model making a decision, especially on the livelihood of an individual, because they need to be merit-based variables.
Now, how good are these? For one, I should point out, it's not just that this feature plays a role, but you have to explain the role that it plays, right? So you can say something like, hey, your FICO score played a big role, but we don't know if it played a positive or a negative role. It sort of contributed towards the approval or contributed towards the denial, something along those lines. So you're not just explaining, it's not just this feature had a big role to play. It's also the actual role that we're sort of pushing towards a yes or pushing towards a no.
Yeah. So I think, and here we start to get into the various stakeholders and the level of explainability that various stakeholders need. So the actual customer, if we're sticking to the credit approval process, they will likely only see the most important factors that contributed to their decision, and they can probably infer based on their own profile whether it contributed negatively or positively. But internally, and actually, I think sometimes, like if you look at your credit report, you will often see that, oh, your credit history isn't long enough yet, so that contributed to your score, which means it affected it negatively. So they even give that sort of of a description. But certain methods, for example, when you run a SHAP, you will actually see the direction very clearly in terms of how it's contributing to the final outcome.
So when you say it's run a SHAP, so let's take a step back for a second. So now we're starting to talk about the tools by which we get these explanations,
Yes.
the tools by which we can point out features that played a role. So, and I know that you're not totally satisfied with these tools, or you're not satisfied with the rules around, or the framework or lack of framework around how to apply those tools. So talk to us about Lime, SHAP, or whatever tools you think are the most relevant ones, and why you're not totally happy with them.
Yeah, absolutely. So I think happy is. I think we just have to be aware of their limitations. We have to be aware that these are approximations and they don't work equally well on all underlying models. And SHAP, I think, is generally accepted in the industry, and it definitely has a robust game theoretical basis. And
what does SHAP do? Just say to a layperson, how would you explain what SHAP does?
so SHAP again can be used locally and globally, but if we're just thinking about local explainability, it's going to give you a list of the top features that were used in the decision making. But the way it does that is actually looking at all the subsets of variables and removing single variables from that to test the impact on the outputs.
Okay.
So this is a simplified version.
Decision over and over again, but with this variable or with this feature, without that feature, with the FICO score, without the FICO score. And it keeps running that same decision.
But even on subsets of variables, because what's important is if you're taking a very simplistic way of doing explainability would be to remove a single variable from your data set.
Yeah.
Right. And retrain and rerun and see how accuracy shifts.
Yeah.
Right.
It's kind of like an elimination diet. We're not really sure what's wrong, or we're not sure why we're getting this output, so to speak, from your biological system. Let's remove dairy and see what happens. And if nothing much happens, you put the dairy back in, and now you remove gluten. And then if it's a big change, you're like, okay, looks like gluten is playing a major role in how your body. But it's roughly analogous to that.
Yes, but then what's the problem with this method? So let's say we have both yogurt and milk in our diet, right? If we just remove milk, but we keep yogurt in, we're not really going to see a change.
Yeah.
And so it's a very naive way of doing explainability where you just take out a single feature and you don't look at the correlations between the features, because one of the other variables can be very highly correlated with the variable you took out, and it will take on the functioning of that previous variable.
Right. So again, to use our analogy, you take out milk, you keep in yogurt. The big issue is dairy here, and it's something like yogurt highly correlates with dairy because, after all, it's a dairy product. It highly correlates with the same thing. So, yeah, that's interesting. So you can't, and so since SHAP operates by removal of a single variable, you might really not be getting to the core of what is actually explaining what's going on in the model. Just like if you just milk, you're not getting to the core of what's really.
So let me clarify here. So what I mentioned here with just removing one variable is the naive way. SHAP is actually much more robust because SHAP looks at all the subsets and removes from all those subsets so it actually shrinks the data sets to the point where it eliminates several variables at a time. Right. So it actually will account for a lot of this. So that's why SHAP is so robust. And that's why it's so widely accepted. And that's also why it's so computationally heavy, because you are looking at a lot of subsets.
Yeah, it's a lot of variables.
Of variables.
A lot of options.
Yes. Yeah.
But so, great. But you're not really satisfied with SHAP, right? Or there's...
Yes, I mean...
You said earlier something, there's Lime and there's SHAP. But can you say something about Lime as well? What does Lime do that's distinct from SHAP?
So Lime is in layman's terms, it's a different approach to that's only a local explainability feature. Basically, what you're doing there is you're creating a localized approximation of the model around the point you want to explain. So it's like, let's say you have this person with a specific profile, and you create a kind of a dummy model around that space of variables, and use that ultimately to explain the decisioning or explain why that happened. Now, again, it's an interesting way of looking at it, and it works as long as the neighborhood of that individual or of that data point is somewhat smooth, and there aren't like big jumps or like stuff happening around it which could mess it up. But again, I think all of these methods are quite useful for explaining a lot of models, but we have to remember that some of them are better for certain types of models than others. For example, we now have various, like Python has a bunch of different implementations of SHAP for different types of underlying models. So you might have deep SHAP, which is specifically for neural networks, or you might have tree SHAP, which is specifically implemented to approximate the tree algorithms well, right? And they also help you save computational resources. You don't have to run the full SHAP. But I think what oftentimes becomes too much of a burden is to do rigorous testing on which methods are the most intuitive and most accurate on the underlying application at hand, because it's oftentimes already a burden to run an explainability method, right? You're developing your model, you have the outputs, you're going for whatever you're trying to maximize. It might be accuracy, it might be ROC, whatever your metric is. And then you're running an explainability method. Now, if you have to also optimize the explainability method, that means you have to benchmark, you have to run through various types, you have to see how that changes as your model changes. It's a lot of burden that that most I think most especially small companies won't have the luxury to be doing that. And so how can we is there a framework around what to use for which cases? And I think there are definitely guidelines, but I think we just have to be careful that we don't get complacent in using a certain method for a certain use case all the time without occasionally checking whether it is really the best method.
Great. So let me make sure that I understand this. So look, there's different kinds of models. There's all sorts of models, different kinds of learning algorithms you might use to create an AI model. And then there are different methods for explaining what's going on inside those models. Not the case that there's sort of one explainability method that rules them all. There's different explainability methods that are appropriate for different models. But you have to figure out what the appropriate one is.
Right.
That takes time and resources.
Right.
Which, slows people down. So I imagine that lots of data scientists don't love doing this because they just want to keep moving.
Exactly.
So it slows things down. And it sounds like in some cases it's also expensive because of the computational power it requires, the computational processing that it could require.
Absolutely. Especially if you run, let's say, a full SHAP. SHAP is the most computationally expensive. And if you run a full SHAP, I mean, it's going to take you significantly longer to run that than to just get an inference from the model.
How does that, when you say it's significantly longer, what are we talking about here? An hour, 10 hours?
Well, it depends how long the model is running initially, but let's say it could be up to 100 times, right? It's a very different magnitude of computational resource versus just running the model. And then we start to get into questions like the carbon footprint, right? What level of explainability do we really need? How accurate does it need to be? And what are some of the trade-offs in running those super accurate ones?
Yeah, that's really, so I mean, there's a couple of issues. So one issue is lazy data scientists will just choose the same explainability method every time because they don't have to go through the whole which one is the appropriate tool for this particular use case. They'll just say, let's just use deep SHAP every time, or let's use whatever, shallow SHAP, whatever you want to. Let's just do that. And that's just going to be inappropriate. You're going to get the wrong results. They'll get false explanations because they're using a method that's not appropriate for the use case. So then there's got to be some kind of guide, or framework, or assessment of what's the appropriate methodology of explainability for this particular use case. That's a lot of work. Then you have the fact that it costs a bunch of money to run these things. And then the nice thing that you've just pointed out now is there's also an environmental cost because we're talking about compute power. And these are questions that data scientists are not going to be, I would imagine, maybe I'm wrong, in a great place to make those kinds of decisions. Is this worth the environmental impact, running this extra test?
Right. I mean, as long as that is not part of their metrics to track, right? That is going to be ultimately a business decision. How do we quantify that sort of impact? And are we thinking about externalities besides cost? And of course, there is a high correlation between the dollar cost of resources and the carbon footprint.
Sure.
So the incentives are aligned in that sense. But yes, it won't be the data scientist who makes that call generally.
Right. And then you need someone who's not the data scientist, but someone who understands what the data scientists are trying to do and why they might or not need to run a certain kind of explainability method. But at the same time, is not so much in the weeds that data science understand the bigger impacts, the bigger kinds of trade-offs that need to be made. And that's a hard person to find or train.
Oh yeah. I mean, if we think about this whole idea of responsible AI and how we approach that, it's ultimately going to be a number of local trade-offs in very different domains that somebody will need to be thinking about.
But I mean, it raises a really interesting issue, which is just that, you might call for explainable AI, but it can't be explainable AI no matter what comes, because it's one value, it's one thing that we might care about among all these other things that bottom line business costs, environmental impacts, time to market. These are tough trade-offs to make.
Yeah, and ultimately, on top of that, the direction that we're moving in, it might not even be that great of an explanation.
Right. Yeah, I mean, I get more and more skeptical that the explanations are legit. I mean, the whole point of AI, this is roughly speaking anyway, is to recognize really complex things that we can't recognize ourselves by just looking at the data. That's why you use it. It could recognize phenomenally complex patterns that we don't see. But the more complex they are, the more complexity you allow them to appreciate, the more unintelligible it is to us. So you turn up the volume on complexity. So you, at least in principle, better insight, more accurate AI, thereby decreasing our ability to understand it. But also, I mean, when you use those explainability tools, it's the more complexity you're simplifying, the more you're distorting the actual phenomenon you're trying to explain.
Exactly. By definition, you need to. Yeah.
And so since we're just adding more and more data, right? We're just adding more and more data to the training data, and we're adding more and more compute power. Just wait, quantum computers that are crunching trillions of data points in seconds or minutes. No way. It just seems to be insane or impossible that we're going to get actual explanations, because it's just the simplification is. I mean, I sort of think, tell me if I'm wrong, it's necessarily going to cross over to the line of distortion if it hasn't already.
Yeah, I mean, if we think about just the large language models, whether it's ChatGPT, GPT-4, we don't exactly know how many parameters, but we've been seeing the parameters and the input space increase. Now, I think there is some hope that we're going to reverse that direction and just start to get more focused on what actually matters in training these models efficiently. But yes, as long as these models are getting bigger and more complex, by definition, we will have more and more distortion in explainability for us humans to actually get some some value out of those explanations.
So suppose I say, okay, we are explainability is so hard. I mean, that's one of the things that I feel is sort of bubbling up from this. Explainability is really hard from a technical perspective, from a business perspective, even from an ethical perspective, because you're trading off things like the value of leaving not having such a carbon imprint with the value of explainability, but both ethical values, they come into conflict. So it's really, really hard, especially as you pointed out earlier for smaller companies, right? So Google, Microsoft, et cetera, they can afford these things, but startups typically can't. So maybe we should just then say it's too hard, involves lots of trade-offs, and maybe we don't need it after all. This goes back to what we were talking about earlier about as long as it performs well, as long as that magic box performs really well, that's all we really need. And so maybe what we have to come to the conclusion of is explainability seemed like a good idea, is a good idea in some sense. It's just not pragmatically feasible. And so we should just move on from it and think about how do we test black box models so that we can ensure that they're sufficiently safe.
Yeah, and I think here we can talk about maybe two branches of AI expansion. I think if we stick to narrow AI and not talk about the whole, the large language models, which are starting to become more and more good at a variety of things. But if we stick to something like a credit decision or a fraud decision, these will remain narrow AI, I think, because it's just more efficient to use narrow AI for these applications. I think we're still going to retain the level of explainability that we need to provide, the reasons to the customer, or to provide that input to the expert who wants to then make the model better, for example. I think we're going to be able to retain that.
We'll hold on to something like these features play these roles major way in the decision.
Yes.
Do you think we'll get that no matter how complex those narrow AI models get?
Well, I think for certain use cases, we're not going to be able to avoid not getting that, because I don't know if regulation will be moving quickly enough. For example, like if you look at the whole fair lending space, you just need to provide this sort of information to borrowers, right? There is no question. And I don't see regulation shifting on that anytime soon, for example. But for newer applications also, it's going to be probably a debate that maybe isn't that much of a debate yet, because for now, I think the general consensus is that we just need explainability for these high risk use cases, especially.
Although you pointed out something really interesting earlier, which is that it looks like even in the current, we don't really have explainability all the way down, so to speak, because there are features that explain why someone got denied or approved, but those features are themselves black box models, like the FICO score.
Yes.
So in fact, it looks like regulations for black boxes, or they need explanation. In fact, in practice, insofar as they allow FICO scores, then they're okay with some degree of opacity, unless do the right get to look into how FICO scores are actually calculated.
Yes, regulators need to have that level of transparency, and ultimately, it's a layered explanation for the user or the client. Because if you think about it, you can also look at the top features of your FICO score.
Okay.
Right. You can look at your Experian report. You can look at your various reports, and it will tell you why your FICO score is at a certain level. And then when you make a credit application, then I think even some of those features might filter out into your responses. I don't know exactly how some of these credit card companies do it, but it's just, again, a layered explanation. And the more we have models embedded in models, the more opaque those explanations become, and the more difficult it is to truly rank the importance of an.
Yeah, that itself is it's kind of nuts, right? Only someone like a regulator is actually going to have the insight into the whole thing, can see all the explanation. You or any, say, data scientist in any big institution, they're not going to have access to looking inside the black box model of, say, a risk score or something like that. Anything I get from the outside, as it were, they're not going to know that. So there's really only regulators who can see the whole process through.
Yeah.
And then, of course, questions about, okay, how do we know that regulators are doing the right thing, et cetera? But that's what's a completely different subject. And how smart and how educated these regulators have to be. And is it going to be a single, does the same regulator say on it? You might say something like, these regulators looked at this black box and this other looked at these other black boxes, and then you take the combination of those black boxes. And so technically, regulators have looked each of the black boxes without any single regulator looking at all the black boxes.
Yeah, and you're right. It's probably unlikely for a single technical person on the regulator side to look at the process from beginning to end. I would think that there is some sort of an oversight, a higher level oversight into the whole process. I don't know the details of that. I don't want to speak for that. But yeah, it's complex. And I think if we think about AI regulation and the decisions that regulators will need to make in order to safeguard the users and the public, but also to allow innovation in this extremely fast-paced acceleration of AI, it's going to be difficult. It's quite a task for them.
Well, it seems to me like, okay, for this narrow AI, we're always going to have some level of explanation. One of the problems I take it that you pointed out is a lot of those explanations are going to be false explanations because the data scientists will have used the wrong explanation tool.
It's obviously possible, right? I mean, if you think about a startup, a smaller company, just starting to develop their models for some sort of a risk classification, they're not going to be audited necessarily, right? There won't be there. You can't always have this sort of independent oversight to ensure some level of consistency and some level of input. So absolutely. I mean, if you were to test 2-3 methods on your same model, very easily can get very different explanations. And then the more complex that model gets, the more likely it is for you to get very different explanations. So it's definitely a lot of resource to get this right.
And then if we shift gears for just a second, let's wrap up with this. When it comes to generative AI, like OpenAI or Bing or Bard, not going to get. I mean, those things are phenomenally complex. Those standard kinds of explainability tools don't apply here, right? I don't think Lyman Chap don't apply.
No.
Of a generative AI. And so it looks like performance is going to be the only thing that we can test it for. I don't think we're going to get explanations.
There is definitely research going on. That's, I think, too cutting edge for me to be able to talk about right now.
Fair enough.
There are definitely attempts at that. But I agree with you. If we can get some sort of comfort from the actual performance of these models and we see them improving, and I think the more people are using them, the more there will be flagging of inappropriate responses, misinformation, false information, hallucinations. We're going to be getting more and more of those things flagged. And I think if we start to see those incidents decrease over time, we're going to start to become comfortable with the model.
I mean, to me, this stuff is getting just more and more complicated. And I don't know. I guess I'm just increasingly. I just think that eventually we're going to give ourselves over to black box models because they perform so well, and we're just gonna live with it. I think that's where we're going. But it strikes me as scary because I think that there are cases in which we probably do. Okay. Hey, Kristof, thank you so much. This was great. I think it's a really fascinating issue, and thanks for helping us understand what explainability is all about.
Thank you for the invite, Reed. It was a great time. Indeed, very, very interesting topic and dear to my heart.
Mine too. All right. See you later.
Bye.